So carrying on, all of these attributes are defined on the class. They're class definitions. This is because they're static typed. That's normally something that programmers avoid in Python because Python is dynamically typed and it's quite fun to be dynamically typed, as well as very practical. The issue is that networks aren't dynamically typed. Computers aren't dynamically typed at the very fundamental level, primarily because there's no such thing as a type of variable, it's simply bits. But the network condenses down to bytes and ultimately bits, and so you have to sort of go back to a very fundamental view of things. In adding support for variable data types, you have to introduce a whole layer of functioning and programming, and you essentially end up with something like JSON. Now, JSON is all well and good, but it's not very well compressed. So firstly, you introduce more bandwidth, and also it requires more overhead. I believe. I could be wrong. They may be more efficient than my own replication system, but that's for another day. I have actually added support for adding different different serializers, but they'll all have to be statically typed. So there's no real use for it. It's only I thought I'd like to introduce construct, the serializer, or sorry, construct the library for handling bytes to data types, which is quite useful. I really like it, but it's in this case I wanted to just get this thing working first. So this currently we have our replicable here, and we have for each of those replicables we go through their channels, and the way in which this works is it creates 64 channels. So that's 64 different objects. And this is slightly, I haven't introduced the connections properly. So this example is slightly flawed in the sense that there's only technically one client connected because there's, there's only one client connected because we're only creating a channel for every new object. We create an object and create a channel for it. Whereas in reality, you create the object once and have 4 or 5 channels if there are 4 or 5 connections. But that doesn't matter because down here, I've just added this in now, but you iterate over all the channels, and we're assuming that each channel represents a connection, which is wrong. So for each we go through all the channels, and then for each of the channels, we go through all the channels again and replicate all the attributes. So in other words, for each of the channels, we go through and replicate all of the other channels. So we end up with a 64 to the power of 2 number of replications. In reality, this would be far less. You'd only perhaps have 5 connected players or 10 connected players, or 18, which is what Call of Duty tends to do. And then, so if I delete this here and drop this down to 18, we're now only replicating 8 milliseconds or 7, and that's when I record. If I stop this and just see how long it runs now, it drops down to about 2, and that's when I'm rendering a video, which on this computer runs quite slow sometimes. So that's that's very fast, and that doesn't even consider relevancy, because of those 18 pretend connections, only a small subset of the actual clients will become relevant to them, of the actors. If they can't see someone, they're probably not relevant. There's no point sending their data. If they can't, if the actor is invisible, again, probably not relevant. And so that's that. Also, I need to add support for physics. At the moment, this pretends that none of these actors really have physics, but they do. They will do. I initially wanted to treat physics like an attribute, and I had problems doing so because, ultimately, when dealing with network attributes are created on the class, which means that for all of the different instances of the class you create, it would all fundamentally have the same value of position and so on. Now, in order to circumvent this, I've forced the replicable to... Is it replicable? I can't remember. No, it's in attribute. The attribute, when you call the register function, it will return a deep copy of the initial starting value. It's not very elegant, but it works. So what I can think about doing now, which I hadn't really been able to do before, is I can now instantiate and return a deep copy. The other thing I can do, which is useful, is send mutable types. Beforehand I couldn't send mutable things like vectors, or you couldn't send lists anyway, but the point still stands, you couldn't send a mutable type because it simply would modify, when you modify a mutable type like vectors, the actual value isn't changed. So I'm not calling the set descriptor on the object. I'm not calling object.position.set. I'm simply modifying the value directly. So this still causes an issue in the sense that it doesn't invoke the flag to say that this variable has changed, but for the conditions. So you'll see here we have an isComplaint variable. If we change any variable which is told to complain when it's changed, this will become true, which can eliminate deep condition trees. We can't invoke that with any mutable types, but we can still check for their value between frames by implementing some form of a hash function. And to do that, it's in replication channel, I believe, and it's in get attributes, and it's down here somewhere. And we call a hash. And I used to use the actual hashing function. I created a special hashing function for vectors. Sorry, I used to use the actual hash value, but hash functions. But hashing is a poor way of doing mutable types because mutable types aren't supposed to be hashable. So in Create, I've avoided using the word hash apart from here, and I've gone to creating a function called static description, and that basically returns the hash of the object. If it's static, or if it's a non-mutable type, and if it's something like if it's specifically a vector or a Euler, we then return a tuple and hash that. And that's technically cheating, but it's for our functions it's fine, and that means we're not actually overriding the hash function. I've also added the option to use the object.description. So if I create my own type which isn't I can't override vectors directly, but if I create my own class where I want to be able to have a special custom hash function, I just add the description. I didn't want the hash function I didn't want to define a hash attribute directly because that could cause issues with other parts of real Python.